hydroelectric power plant contributes 52% of the overall renewable energy production done within the country. It utilizes the potential energy of water at a high level for the generation of electric power. The falling water rotates the turbines, which in turn brings shaft of generator in motion. The generated electric power is stepped up and transmitted at high voltages of 132 kilovolts or 66 kilovolts. Generating electricity from falling water started in 1849 when Fournier and James Franchi created the modern water turbine. Hydroelectric plant consists of control gate for allowing water intake, penstock which provides closed conduit for water to flow, then water enters powerhouse where transformers, turbines, generators generate electric power and transmit it to the power. Intake helps in diverting and preventing the entry of debris and ice into the turbines. Forebay is a regulating reservoir storing water temporarily just above the intake. Penstock is a closed conduit which connects forebay or surge tank to the scroll case of turbine, built with steel and reinforced concrete to withstand hydrostatic pressure and sudden surges. Surge tank is located as close as the power station as possible. It helps in stabilizing the velocity and pressure in the penstock and reduces water hammer, negative pressure and vacuum. Hydroelectric plant contains water turbines based on the capacity of plant. It serves the purpose of prime mover, which converts kinetic energy of fast flowing water into mechanical energy, which is further utilized to drive the alternators generating electric energy. Energy produced is stepped up and removed from harmonics, then transformed and passed to the transmission lines. After useful work is done by water, it is discharged to the tail race and back to the rail.
So now I am going to demonstrate stimulation model. In this stimulation model, there are four major parts. One is synchronous generator, one is hydraulic turbine and governor, one is excitation system, and last is control panel. So here is synchronous generator, and the rotor of synchronous generator is connected to the shaft of turbine. When the turbine rotates, the rotor also rotates. So when the excitation is given to rotor of synchronous generator and it rotates, then there is the voltage induction in the stator. And this A, B and C are the terminal voltage output from where we get three phases. And this PM, it is a mechanical input to generator which is coming from the hydraulic turbine and governor. And now this is M, which is data bus which send various data measurement from the generator to the hydraulic turbine and governor and excitation system. After this, bus measurement information goes to hydraulic turbine and governor. So hydraulic turbine and governor detect the change in rotor speed and other parameters, and then they alter the guide vanes case to control the water flow. So by controlling the flow of water, we can control the speed of turbine. So now coming to excitation system, this excitation system is used to excite the rotor winding, and this control panel, here we can see various output like excitation voltage, rotor speed, phase voltage, phase current, stator current. And now I'm going to demonstrate you how this model works. So we have to run this model. So it takes few seconds to run this model. So now you can see that this model is running. So you can see various output from this control panel. Now I'm going to show you one of the output, that is rotor speed. So after finishing this compiling, now click on the rotor speed. Now you can see that after starting the rotor generator, we can see that this rotor speed is going to be synchronous because we are using the synchronous generator. So at the starting, maybe it is not synchronous, but after a few seconds from the starting, we can see that the speed of this rotor is going to be synchronous. You can see from here that this speed is going to be synchronous, so these peaks are decreasing with respect to time. And after a few time after the starting, this peak should be going to zero and it becomes synchronous speed. So now you can see that there are stator current. Stator current, by clicking on stator current, we can see various A, B, C stator current. So these are the stator current. You can see that at the starting also here, these stator current are high, but after few these you can see that these are the waveform of three-phase stator current. This waveform is not clearly visible, so now I am going to reduce the stop time. From here we can reduce it like for 0.5 seconds. Now run this model. Now you can see that stator current, yeah, these are the three-phase stator current, the blue, red, blue and yellow. So here similarly you can see that the phase voltage and excitation which we are giving to synchronous generator. So thank you.